Let me use pink, I guess. Come back and use pink. So I'm gonna box them so make evens, right? So 1, 2, 3. There are my even cards. The rest are gone. Bye-bye. Gonzo, whatever you want to call it. Right? So all the rest of those cards are gone, right? So how many blue cards do I have in this space?
Same.
2 out of how many total, though? 3. I'm just pointing out those two things are not the same. They typically aren't. Questions about calculating this probability? Another thing, again, just pointing out, I'm using, right, what I do to calculate these. If you're not sure where I'm getting these again, use the formula. It's easier. It just takes a little longer. That's all it is. Right? So use the formula. Right? That P of, right, A and B over P of B or whatever it is.
Professor,
Oh, yeah.
will we have a chance to go over this tomorrow? This is really...
Yeah, we can ask questions about it. Always. So the events of R and B are what? Oh, because P of R and B is 0. We know these are mutually exclusive. Yeah. Blue and red can't happen together in this scenario. All right. Let G equal the card with a number greater than 3. So card with a number greater than 3, that would include 4 and 5. B, particularly B4 and B5. Blue 4, both blue 5. So my probability of G is 2 out of 8 total. Going back to the original sample space now. Let H be a blue card, number between 1 and 4. So B1, 2, 3, and 4. I have those 4 cards in this set. So now we think about the probability of G given H. So there's G, right? Given H occur, that means this is my new sample space. I'm not considering this sample space anymore up here. My new sample space, yeah, Ro. Yeah, sure. Yeah, let me finish this up real quick. So, right, so this is my new sample space. So how many of these G cards do I have in there?
1.
So this is a little weird, right? So it's a little. Oh, let me not use orange because you can't really see the difference. Let me use green. All right. This is the only one in G that's also in B, so I can't even get this possibility when I'm considering this, right? I know I'm in here. I know. All right, I got 1 through 4 blue card, 1 through 4, kind of thing. So I can't have this one blue card that's already in this, because I know I'm in the space. That's what this given statement says. So I have 1 out of 4 possibilities. Can I show it with this one, Ro? Would that be cool? Yeah. Just to finish this statement up, and then I'll go to Ro's question. All right, so noticing, right, P of G is 2/8. 2/8, also known as 2/8, also known as 1/4. 1/4 is equal to this 1/4. These two things are equal, is what we're saying. So check. That means they are nice. That right there. These two things are equal. We can go.
Yeah.
One is independent of the other. Knowing one happened, it doesn't change the outcome of the other. One occurred, it doesn't change the outcome of the other, the probability of the other. All right, going through what Ro was asking. Ro said, right, let's try and do this the other way instead of Andre's way. So, right, so P of G given H. I want to calculate this. I'm going to use P of, what's it? G and H over P of H. Yeah. So calculating P of G and H. So P of G and H. The only thing in common between G and H is B4. I have 1 out of 8 things in my original sample space. All over P. Sorry, I got way too low. Right, I got 1 out of 8 for my P of G and H. I only have one thing in common between those two. All right, whereas my P of H is I got 4 things out of 8.
And then just cross them.
And then cross the denominators out. You got the 1/4. So you try it on the other page. Why don't you go ahead and try it? Just finish it up in 5 minutes. Compare it to your neighbors. Right? If you feel comfortable with it, right? Move on. We can take it down. We can go on and take it a little early, or you can stay and ask questions, or hang out with me because I'm cool. Hey, why would I?
Nah. I'm going to chapter 3. Independence. I guess we can stop this now.